This call is now being recorded.
So the memory capability of finite automata is very limited. It can memorize current input symbols only, and it cannot memorize previously processed symbols. Hence, by adding extra memory to the finite automata, we will get PDA. Some of the limitations presented with finite automata is majorly the memory. So we are adding some more memory to the finite automata, that we can call it as like a push down automata. FA with stack is known as the push down automata. See here, this is the black diagram of the push down automata. Generally, this information is not presented. On the right hand side, we have extra element called stack structure. We have in FA these two elements, components. First one is the input tape, and this one is the finite control. Only these two components are presented in the finite automatas. But whereas in push down automata, we have one more component, stack structure, where we can store the information. So we have extra memory concept. FA with stack is known as the push down automata. So it is consisting of push down automata is consisting of three components: input tape, finite control, and stack structure. Input tape is divided into n number of blocks. Each block will store one input symbol, and this is the read-write controller. Finite control, we have one read-write head. So that read-write head scans each square in the input tape and reads the input from the tape. So the head will move from left to right only. Left hand side is not possible. It will move. If it has taken one input, it reads one input, and the read-write head will move to the next block likewise. And then finite control can be considered as a control unit of a PDA. An automata always resides in a state, some particular state, Q0, Q1, Q2, for example, like that. The reading head scans the input from the input tape and send it to the finite control. So a two-way head is also added with the finite control. One is points to the stack, top of the stack. One is pointing to the input tape. And stack. A stack is a temporary storage of the stack symbols. Every move of PDA indicates one of the following to the stack. Either we'll perform push operation onto the stack, we will add one stack symbol to the stack, or we'll pop the symbols from the stack. And in stack, initially it will contain Z0. Z0 is the default value presented. It will represent the bottom of the stack. So this is the push down automata. And what are the limitations of FA? Black diagram of PDA, elements or components of the PDA. Then definition of push down automata. In finite automata, we have 5 tuples, and in FA with outputs, we have 6 tuples. Now we are going to the next one, push down automata. Second type of automata, that is push down automata. It will consist of 7 tuples. It will consist of the 7 tuples. So it consisting of the 7 tuples. What are those tuples? So here we know some tuples: Q, sigma, del, Q0, and F. Is it not? We know some of the tuples here: Q, sigma, del, Q0, and then F. Q represents the finite set of states. The number of states presented in the given push down automata will be given by capital Q. The total number of set of states, whatever presented in that push down automata, will be represented by capital Q. And sigma represents the input alphabets. Sigma represents input alphabets. And del is the transition function. Del is the transition function. For present input state, if you give some input, what will be the next state? will be given by the del, that is nothing but transition function. And Q naught is the initial state. In these automatas, we'll have initial state and final state, where we have started, where we have reached. So Q naught will be represented by the initial state, and F will represent the final state. F will represent the final state. Okay, this is fine. Already we know these 5 tuples: Q, sigma, del, Q naught, and F. Here we have extrally 2 symbols, gamma and then Z naught. Z naught already I introduced here. So the bottom of the stack will be represented with Z naught. In the stack there is always a symbol Z naught, which denotes the bottom of the stack. So the stack, if it is empty, it will consist of Z naught. The top of the stack always consists of the initially Z naught. So Z naught is the stack bottom symbol. Z naught represents the stack bottom symbol. And what is this gamma? So we are using here extra stack. In PDA we are using extra stack. For storing of the stack symbol, we are using an element called gamma. So that is finite set of stack symbols. So totally pushdown automata is consisting of a 7 tuple: Q, sigma, del, Q naught, and F. Q represents finite set of states, sigma represents input alphabets, del represents the transition function, Q naught is the initial state, F is the final state, Z naught represents the bottom of the stack, and then gamma represents the stack input symbols. So whatever the symbols presented in stack will be given by gamma. Okay, fine. Is it clear?
Yes, ma'am.
So totally it consists of how many tuples? PDA consists of
Ma'am.
PDA consists of
7 tuples.
7 tuples. Yeah, fine. So now transition function. In transition function, finite automatas will have only 3 tuples. Q into sigma tends to Q. Present state, Q represents present state, sigma represents present input. So for present state, if you give some input, what will be the next state? Will be given by the finite automata. So there we have only 3 tuples. Q into sigma tends to Q. But here in PDA we'll have 5. Because Q, what is the present state? Q represents present state. Sigma represents present input. Up to here it is common. Q into sigma, which means Q takes the present state. Sigma represents the present input and stack symbol also. So we should know what is the symbol presented on stack also. Before that we have only input take and present state in the control unit. There is no stack presented. So at the time we are not adding, we are taking present state and present input only. But now we have even stack also. In that stack we have input stack symbols. Now we need to consider that one also. So that's why Q into sigma into gamma. Gamma in the sense stack symbols. Sigma is input symbols. Gamma is stack symbols. Tends to Q into gamma star. Q represents what is the next state. So Q will use next state. So for present input, for present state, input is taken from input alphabets and input considered from the stack symbols, which gives what is the next state. So what is the next state will use. And also, what are the remaining symbols are presented in the stack if A is processed. Now what will be the next input and what are the next remaining symbols presented in the stack should also be represented. So that's why here we'll have 5 tuples. Q, sigma, gamma tends to Q into gamma. Present state, input from alphabets, input from stack. What is the next state? What are the remaining symbols presented in the stack? So this is how we will represent transition function in pushdown automatas. Whereas in finite automatas, we'll have only 3 symbols. Q into sigma tends to Q. So we'll have only 3 tuples. So that is the difference between pushdown automata and then finite automata. Okay. See here, transition functions examples. So a move in PDA may indicate. So if one move maybe in pushdown automatas may indicate that an element may be added to the stack, that is push operation we can perform, or else an element may be deleted from the stack, that is we may perform the pop operation, or else there are no changes of a state, may or may not change of the state. State might be the same the previous one. For example, consider here Q is the present state, A represents the input from the alphabets, Z0 represents the initial or bottom of the stack. So now we are performing push operation. So push operation, when you perform, Z is the bottom of the value. If you push A onto that stack, what happens? A will be inserted on the top of the Z0. So now the next state will be the Q, and the symbols in the stack is A Z0, because A is pushed down to the stack. Z0 is already presented. So above the Z0, A is pushed. So now it will becomes, while reading, Q0 comma Z. So if you are popping in stack, we have A. Now we are popping the A from the stack. Now what happens? Q comma A comma Z0. Always pop operation, here second element should be epsilon. So Q comma epsilon, which represents pop operations we are performing. When you pop this element A or something, we'll get epsilon, nothing. So that is pop operation represents. So this is the definition of PDA and differences between what are the limitations presented with finite automata. So black diagram of PDA, what are the elements presented in PDA, and different definition of the pushdown automata. PDA with consisting of 7 tuples. What are those 7 tuples? And then PDA moves. So PDA will perform either stack, push operation or pop operation. So now we will see graphical representation of PDA. Graphical representation of PDA. How we can represent it is in the form of transition diagrams. So for example, consider we have a PDA M. We have one PDA with name M, which consists of 7 tuples: Q, sigma, del, Q naught, F, gamma, and Z naught. Where Q is nothing but set of states. The set of states are 2 states, P and Q. And then sigma, input alphabets. The input alphabets are A, B, C. And then gamma. Gamma represents the stack symbols. That is A comma B. And Q naught is the initial state. Here Q naught will be considered as Q, and final state will be P. Initial state will be the Q and final state will be the P. Now transition function del is given by here in the following equations. See here Q comma A comma epsilon. So A nothing. So we are pushing A onto the stack. State is not changed. Here also Q, here also Q. Next one more time B we are pushing. So Q comma B. C pushing. So C, it's a pop operation, either push nor pop operation. Whenever here we will get epsilon, that we have to consider as the pop operation that we are representing. Q is the present state, A is the input, and stack symbols are nothing. So when Q as given as A as input, it will goes to the next state Q only, and the output will be the A. So the stack symbols will be the A. Likewise, we can represent all the things. So the next one, instantaneous description of a PDA. During processing of the PDA, the PDA moves from one configuration to another configuration at any given instance. The configuration of PDA is expressed by the state of finite control. The content of the stack and the input. The configuration is expressed as a triple. So Q comma X comma Y, where Q is the state, X is the input string to be processed, Y is the content on the stack, where the leftmost symbols corresponds to the top of the stack and rightmost is the bottom of elements. When it's thing but instantaneous description is nothing but showing of how the string is accepted with three elements we will show with triple. Q represents the state, X represents the input symbols, Y represents the stack symbols. See here, this is the string. Q is the present state, this is the string, and in the Y we are taking the content of the stack. Initially the content in the stack is nothing, so epsilon we are taking. Now Q comma epsilon, A comma epsilon. What we are performing here? Q comma A comma epsilon. We are performing push operation. So whatever the symbol is taken from input, we are pushing that input onto the stack. So now we are pushing here the input A into the stack. Now what happens? Q comma, this A is pushed onto the stack. A will become top of the stack now. B, A, B, C, B, A, B will be the remaining symbols input presented. Next, it will process A. B. Again Q comma B comma any state A. Again we are performing push operation. So B also will be pushed on to the stack. Then again next to B will be pushed and C will be nothing we had given for C. Q comma C comma epsilon, nothing we are performing, neither push nor pop we are performing. So all the things will be presented like that only. So BAB will be present like that only. BA will present like that only. So nothing changes will happens here because no changes we had given for Q comma C comma epsilon. Neither push operation nor pop operation we are doing. So and same B with B, Q, P comma B with B. So we are performing Q comma P comma A. Here we have changed Q with P state. We are not performing any push operation or pop operation. We are simply performing state change from Q to P. P comma A presented, then we'll perform pop operation. So what happens? Q comma A. Both B will be popped. Then again A will be popped. Then again B will be popped. P comma epsilon comma A will be presented. So this is instantaneous description of a PDA. With triples we will represent state, input from alphabet string to be processed. Y is the remaining symbols contains presented on the stack. Then, so language acceptance by PDA. Generally in FA, whenever we reach the final state, we tell that the given string is accepted by the given finite automata. The only way we will check. But whereas in pushdown automatas, we have two ways. By using any one way, we can give the acceptance of a string by the pushdown automatas. First one is acceptance by final state as like FAs. If PDA accepts inputs by consuming it and finally it enters into the final state. So that is one method, acceptance by final state. And coming to the next one, acceptance by empty stack. Not only by reaching of the final state, and also we can give the acceptance of a string by emptying the stack. This is extra method because we are extrally using one more element called stack. So by emptying the stack also we can give the acceptance of a pushdown automata. In finite automata we have only one method, that is acceptance by final state only. But whereas in pushdown automatas we have two types of acceptance of a string, that is acceptance by final state and acceptance by empty stack. On reading the input string from the initial configuration for some PDA, the stack of PDA becomes empty. Now we'll see one example how to construct PDA. So which has to, it is a power n and b power n, where n greater than or equal to 1. So at least one AB should be presented. N greater than or equal to 1. For this language, we need to construct a PDA. It is difficult in finite automata. A power n, b power n, which means how many number of A's are presented, that many number of B's should be presented. So how A presented number presented with has of A's that many produce. To A down, so it is standard. It takes A as input and it will perform A will be put onto the stack operation. Right now, A is given, A will Q0. When we apply B for Q0, it is moving to the pop operation. Same Q1 with B, we are performing pop operation. See here, we had given. So initially, we had to write strings. So you take a note of strings accepted for this language. Strings A power n, B power n ki raayandi. Some of the strings for A power n and B power n. Write some strings for A power n and B power n. AB minimum string, AA, BB second string, AAA, BBB, 4A's, 4B's. Likewise, we can take how many number of A's are presented, that many number of B's should be presented. So first, what is the idea behind here? Whenever we are getting A's, simply we'll push on to the stack. Whatever the any number of A's we will get, we'll simply push on to the stack. Once if you got B's, then perform pop operation. So we'll perform pop operation from the stack. While whenever the input has been completed with all B's, at this time, stack should become empty, so that our string should be accepted. because number of A's already we had pushed down to the stack. Now we are reading only remaining B's. The condition A power n, B power n. So if there is a 2 A's, there should be a 2 B's. So if you read 1 B, we will remove one, we will pop 1 A from the stack. So 1 B, 1 A. Next, we'll remove second B. At the same time, we'll pop the second A from the stack. So now, likewise, we'll perform the operations. If stack is empty and input also empty same time, then A power n, B power n condition is satisfied. If not like that, some of the symbols are left over in the stack or input, then we can consider that the given string is not belonging to the given language. So we'll see the diagram and we'll see the function. See here, what in present state, if you get A, just push on to the stack until unless how many A's you'll get, will push. Now on top of the stack we will have A. Now again with A we may get A. A is inputted, this A represents the stack symbol. Again we are getting A. So we'll push that A onto the stack again. So Q naught comma AA. Now if you get B, so we have to remember. So we will change the state from Q naught to Q1. So now we are performing pop operations. So Q naught comma B comma A. So now it will become Q1 comma epsilon in the sense epsilon every time. So it will indicate the pop operation. So we are popping. So B from stack learner. So we are popping A from stack. For 1B, 1A we are removing. Same next we will change state. So in Q1 state again if you get B comma A will be in the same state and we will remove epsilon. So sorry, we will pop A. So we will perform pop A. So now nothing is presented. All the inputs as red. And bottom of the stack is consisting of only Z naught. So del of Q1 comma epsilon comma Z naught equal to final state. So it is acceptance by final state. QF comma Z naught. Is it clear till here? Transition functions. Is it clear? Is it clear till here?
Yes, ma'am.
The next one. So we already I told that we have two types of methods for string acceptance. One is stack by empty or else one is using final state. By reaching the final state, we can check the string acceptance. See here we are taken AAA triple B B. So AAA triple B B. So now step 1 initial configuration. Stack will consist of Z0 and input type is consisting of A. So Q0 comma A comma Z0. What we had written Q0 comma A comma Z0. So what we had written. So simply we are performing push operation. We'll push A onto the stack. So A will be pushed onto the stack. So now the stack will become Z0. Above the Z0 we have A. So automatically the read write head will move to the next block. So the next block again Q0 comma A comma A. So we no need to bother any number of A's can be presented. We'll simply store all the A's into the stack. Once if you caught with the B, then we'll perform the pop operation. So here A it is getting A comma A, Q0 comma A comma A. So now also Q0 comma A also push operation. We perform A onto the stack. So A will be pushed. Now next the thing A will B. So A is pushed onto the stack. So Q0 comma A comma B. So 1B started. So now 1B for 1B if you remove 1A, if we empty the stack, empty the input tape, the stack should also be emptied. For that one, Q naught comma A comma B will perform pop A and change to states. So likewise, we'll write the steps. So by using final method, final state method, language acceptance by PDA. So we'll check the acceptance. We are here performing acceptance by final state only, because Q naught epsilon z we are reaching it to the final state. So now we are checking language acceptance by the PDA by using final method, by using final state method. Q naught comma A Z naught. A we have to push. So Q naught comma A Z naught. Again A push. A Z naught. Again A push. A Z naught. Now B is presented. We have to change the we have to perform the pop operation for 1B, 1A. So for 1B, 1A will be popped. For second B, we are getting A. So opposite direction. So we have to perform pop operation. Then again BB comma AZ naught. BA again will remove. BA again will perform pop operation. So Q1 comma B comma AZ naught. So these two are also popped. So now it becomes Q1 comma epsilon comma Z naught. Now Q1 comma epsilon comma Z naught will leads to pop operation. So it is reached the final state. String is accepted by Pushdown Automata, reached to final. So it is reached to the final state and string is empty. So design of a PDA which accepts equal number of A's and B's over a given sigma equal to A comma B. So likewise you have to construct. Is it clear? Language acceptance by PDA. Same the thing with diagram and checking of the string. So design a PDA that accepts L equal to A power 3, B power n, C power n. So the PDA is of two types, deterministic PDA and non-deterministic PDA. So a PDA that has at most one choice of move in any style is called as a deterministic. So it's a deterministic PDA. Non-deterministic PDA provides a non-determinism in the moves defined. Deterministic PDAs are very useful in programming languages. Non-deterministic, if and only if del of q comma a comma x has one or more movies. Non-deterministic, if and only if del of q comma a comma x has one or more moves. You try for this one, design a PDA which accepts L is equal to W power of R such that W is in A plus B whole star. This I explained for context-free grammars. I explained in context-free grammars. So you go with the reverse of a string, designing of a PDA. Is it clear? So in today's class, we have discussed about the limitations of FA, what is definition of PDA, and then structure of a PDA or black diagram of a PDA, and then definition of pushdown automata, and how many ways we can represent graphical representation of PDA, and then instantaneous ID and kuda antaramma dinni. We can also call it as like ID, instantaneous description of PDA. So how to represent, and language acceptance by PDA. So language acceptance by PDA. So in transition diagram, transition function, stack empty method, final method, and design of PDAs. So this is what we had studied in this class. Is it clear? And types of PDAs, deterministic PDAs and non-deterministic PDAs. Is it clear, ma?